Hello and welcome back. The following question states sodium peroxide is used to remove carbon dioxide from the air supply in spacecrafts. It works by reacting with CO2 in the air to produce sodium carbonate and oxygen with the following balance equation. What volume in liters of CO2 at STP will react with a kilogram of sodium peroxide? So, when we are looking at this problem, we need to first identify what they're giving us and what they're asking. Well, they give us the following balance equation, and they're telling us that sodium peroxide reacts with CO2 to form sodium carbonate and oxygen. They're asking us for volume in liters of CO2 at STP will react with a kilogram of sodium peroxide. So, right off the bat, we know we are dealing with standard temperature and pressure, so that's STP. So temperature is equal to 0 degrees Celsius, so 273.15 Kelvin. And we are also dealing with 1 atmosphere. They give us a kilogram of sodium peroxide, so I'm going to write that right here. So they have 1 kilogram, so I'm going to do 1,000 grams of sodium peroxide. Oops. Oh, that's right. Sodium peroxide. So what we're going to do is we're going to use the ideal gas law and the balance stoichiometric equation in order to find the volume in liters of CO2. We know we can convert 1,000 grams of sodium peroxide to moles of sodium peroxide. We do this by using the molecular weight of sodium peroxide. So 1 mole of sodium peroxide divided by 77.98 grams of sodium peroxide. Grams and grams cancels out, and we end up getting moles of sodium peroxide is equal to 12.82 moles of sodium peroxide. The reason why we had to convert to moles of sodium peroxide is because in order to use the balance equations and the stoichiometric relationships between them, we had to convert to moles. So once we're in moles of sodium peroxide, we can then use the stoichiometric ratios in order to convert from moles of sodium peroxide to moles of CO2. The reason why we are going to moles of CO2 because we're looking for the volume of CO2 at STP that is required to react with a kilogram of sodium peroxide. Well, once we find the moles of CO2, we can then use the ideal gas law to solve the remainder of this problem. So we know 12.82 moles of sodium peroxide react with, it's a 1-to-1 relationship, so 2 moles of CO2 react with 2 moles of sodium peroxide. So moles and moles cancels out, and we're left with moles of CO2 is going to be equal to 12.82 moles. Once we have this, we can then use PV is equal to nRT, so the ideal gas law equation, and solve for volume. This will be equal to moles times the ideal gas constant times temperature divided by pressure. We know moles, we know R, we know temperature, and we know pressure. So we go ahead and we plug everything in. We end up getting 287.4 liters of CO2. So let's do a recap of what this problem is asking for, how we solved it, and how we went about it. So they tell us the following stoichiometric equation, and it's balanced. 2 moles of sodium peroxide reacts with 2 moles of CO2 to produce sodium carbonate and oxygen. They asked us what volume in liters of CO2 at standard temperature and pressure will react with a kilogram of sodium peroxide. So they give us the mass of sodium peroxide. We convert that to moles of sodium peroxide, which we did by multiplying by the reciprocal of the molecular weight. So grams and grams cancels out, and we're left with moles of sodium peroxide. So we have 12.82 moles of sodium peroxide. We then use the stoichiometric relationship in the balance equation to convert from moles of sodium peroxide to moles of CO2. Once we found moles of CO2, we can then use the ideal gas law to plug in the moles of CO2, our R constant, temperature divided by pressure, which we know temperature and pressure are 273.15 Kelvin and 1 atmosphere because they tell us standard temperature and pressure. Once we did so, we plugged everything in and we got a volume of 287.4 liters of CO2. Hopefully you were able to follow all the steps. Please make sure to re-watch this video if you didn't catch something along the way. Thank you.